1.
Welcome to the Consulting Specifying Engineer webcast, Lighting, Designing a Holistic Lighting System, sponsored by Lutron. I'm your moderator, Jack Smith, with Consulting Specifying Engineer and CFE Media. Here are some tips for today's webcast. If you are having trouble with your slides or sound, refresh your browser or click the Refresh Media button directly under the presenter's photo. You can control the volume settings by adjusting the volume on your computer. If you're having technical problems, click on the question mark at the top right corner of your screen to bring up a list of system checks to try before contacting an online technician. If you do need a technician, type a message into the Ask a Question box, and someone will respond as soon as possible in the Answered Questions box. Type questions for today's expert presenters in the Ask a Question box on the left side of your screen. The Q&A portion will start after the prepared presentation. So that means that we'll begin in about 45 minutes. If you are on Twitter, tweet your questions to us at #CSEHolisticLighting. Today's webcast is being recorded, and you will receive an email with a link to the archive in about a week. To download the presentation slides, use Event Resources on the left side of your screen. For those of you who are interested in receiving one AIA-CES approved learning unit for this event, you need to pass a 10-question exam. To take the learning unit exam and download your AIA-CES certificate, use the Learning Unit Exam tab option at the top of your screen. The exam will open in a new browser window, so if you want to take the exam after we're all done, I suggest you open it now because the link will break when the webcast signs off. The exam will be posted on the Consulting Specifying Engineer website with the on-demand version of the webcast. In keeping with the American Institute of Architects Continuing Education System policy, please take some time to review the quality assurance slide. Here is a list of learning objectives for today's webcast. We'll touch on these in today's presentation. Please note that any blue underlined text you see in today's presentation is a hyperlink to use or a resource. To download the presentation slides, use Event Resources on the left side of your screen. Now we'll hear from today's sponsor. At the conclusion of the commercial, you may experience a few seconds of silence to make up for various internet speeds. Please stay tuned after the video for today's presentation.
We know it can be challenging to navigate energy codes. They differ by jurisdiction, and they're updated every few years. So when it comes to specifying lighting controls, it can be hard to know where to start. Do I need a system that can provide demand response? How many controlled receptacles do I need? And when do I need occupancy sensing or daylight harvesting? Lutron helps you cut through the clutter and get your job done. The online tools we've designed make the code process simple. Lutron helps you verify the energy codes in your project location, design confidently with code-based application guides, and create your documentation quickly with room-based design files. Now, these tools all demonstrate how easy it is to meet code with the Vive wireless system. Vive is a simple, scalable, wireless lighting control system that has been designed to minimize the guesswork. The system meets all major energy codes and is simple to design, install, commission, and operate. And Vive does more than just meet code. It grows with your needs. With Vive View system management software, you can get advanced energy reports, analyze space utilization, and manage your lighting control system from an easy-to-use graphical floor plan view with no additional hardware. With Vive, you can scale your code-compliant system into a smart building solution. Vive by Lutron makes meeting codes simple and has a smart building lighting control solution for a wide range of applications and virtually any budget. So learn more about Vive and Lutron's other smart building solutions today.
Now I would like to introduce today's dynamic duo. As the managing principal of Integral Group's Washington, D.C. office, Sarah Lapano is responsible for developing client relationships, pursuing project opportunities, and leading the team of engineers and sustainability experts in the office. With a background in architectural engineering with an emphasis on electrical lighting design, Lapano's design focus is to incorporate sustainability into every project. She was a 2016 Consulting Specifying Engineer 40 Under 40 award winner and is a member of the Consulting Specifying Engineer Editorial Advisory Board. Sarah Schonauer leads the Canon Design Lighting Studio and couples her extensive lighting design experience with a deep understanding of architectural design and building systems to bring seamlessly integrated solutions to clients. She has written several articles for Consulting Specifying Engineer, and she was a 2017 40 Under 40 award winner. Because we have the double Sarah effect happening today, I'm going to refer to each of you with your last initial or name. Audience members, as you type in your questions, please refer to Sarah L. or Sarah S. when you direct your questions to a presenter. Sarah Lapano, it looks like you're kicking off today's session, so take it away.
Great, thanks, Jack. And again, I'm Sarah L., Sarah Lapano, and my emphasis today will be more on the engineering aspects of lighting, while Sarah Schonauer brings more lighting design experience to our presentation, so we'll kind of be discussing those two aspects of lighting. So I'm going to start with going through lighting codes and standards. I'm going to start with building codes, end with energy codes, and then go through some more of the optional strategies and certifications in the middle. So to start off, there's a number of building codes that impact lighting design for buildings. The International Building Code includes a fire code that has some requirements. The National Electric Code also has some lighting requirements, as well as NFPA 101, the Life Safety Code. So it's a number of different codes, even in addition to the Energy Code, that you need to be referencing as you're designing lighting for buildings. Also, if you get into some more specialty applications such as healthcare, there are even more codes that apply that you will need to make sure you're incorporating into your design work. So building codes primarily cover, in regards to lighting, what the egress lighting requirements are for buildings. And egress lighting is the lighting that occupants need to have in order to safely exit a building during either an emergency event or during a power outage. So these codes dictate what the fairly minimal light levels are that people need to be able to get out of a building safely. They also identify the spaces that require this type of lighting. And you'll see that they do have requirements both for interior lighting for paths of egress, as well as some exterior lighting, primarily the points of the building where people exit, to have enough lighting for people to exit away from the building safely. And there is a CSE Magazine article on this that goes into a lot more detail on these codes, and there's a link to it on this slide if you download the presentation afterwards. So then moving on to design standards and guidelines, the major organization that publishes guidelines for lighting design is the Illuminating Engineering Society, IES. It's worth noting these are not actually adopted as code requirements. So from a legal standpoint, like when I'm stamping drawings, it is not a legal requirement that you meet these recommendations. But these recommendations are usually the basis for the light levels that we're designing our spaces to. And in addition to just the general lighting handbook that they publish, which is a very large publication that covers almost every lighting scenario you can think of, they also have more focused recommended practice publications on things like exterior lighting for roadways or parking lots and things like that. So those are more focused on specific applications. It is worth understanding this because I will frequently get questions on projects asking, for example, what's the code requirement for lighting in a classroom, and while we might design to 30-foot candles, that's not actually a code requirement. The code just covers the egress lighting that people need to exit. So it's worth understanding this because this is where professional judgment comes into play with what level the lighting is designed to. You then have optional certifications, which probably a lot of you are familiar with. Things like LEED and WELL both have requirements that cover aspects of the lighting design on projects. It's worth noting, even if you're doing a LEED or a WELL project, you still have to make sure that you're complying with the local codes as well. So these are not in place of a code, they just have additional requirements that you need to do in order to obtain these certifications. So I'm going to spend the most time on energy codes. There's 3 major energy codes that we encounter on our projects, typically. The International Energy Conservation Code, IECC, ASHRAE Standard 90.1, and California Title 24. So the first question when you're starting a project is to identify what energy code you are actually required to follow. So there's a link on the screen here to a website that provides a list by state of which energy codes have been adopted. Each state adopts their own energy code. It also is worth noting which year specifically is adopted because, as we'll go through, there's numerous years for all of these different codes. And it's worth checking, some cities and other smaller jurisdictions will actually adopt energy codes even more stringent than the state level. So it's making sure that the jurisdiction you're in, that you are aware of what the required energy code is. So the IECC, it's published by the International Code Council, which publishes a number of different model codes that can be adopted. So the energy aspect of it is one of several codes that this group issues. Jurisdictions do adopt each code individually, but normally they'll adopt an entire suite of ICC codes from a certain year. So that's normally what we see on our projects. The IECC issues updates to its code every 3 years. The most recent version is 2018. And this covers all aspects of energy efficiency for buildings, envelope, mechanical systems, all different aspects of things that might consume energy or impact energy, which also then includes lighting. What you'll also sometimes see is jurisdictions adopt supplements or amendments to this code. So they'll basically use this code but have it be modified or redlined in a certain way based on their priorities as a jurisdiction. It's also worth understanding the IECC does reference ASHRAE 90.1 as being an acceptable alternate compliance path. So that actually means if a jurisdiction has the IECC as its adopted energy code, you are allowed, per the IECC, to use the ASHRAE 90.1 code as an alternative way of complying. You need to have the entire team doing this, though. So you wouldn't, for example, be able to have the lighting team following ASHRAE 90.1 while the architects are designing their envelopes per the IECC. So it needs to be a comprehensive decision for the team, but you are allowed to basically choose ASHRAE 90.1 as an option. And you basically would refer to whatever version of ASHRAE 90.1 was issued just before the IECC. So that's just worth noting. So then on to ASHRAE Standard 90.1. They also issue updates every 3 years, but they're 2 years off of the IECC. The most recent one was in 2016. I was just checking. I do not see the 2019 version being issued yet, but they should be on track for getting that out this year based on the 3-year cycle. And it also covers a similar scope to what the IECC does, all aspects of building systems and envelope design that impact energy. Lastly, California Title 24. It's fairly unique because it's really one of the only statewide energy codes that are not based on either ASHRAE 90.1 or the IECC. However, it does have a similar scope to those 2 codes. It just has different requirements from an energy standpoint. So one thing I'm going to spend a little time on with lighting systems and how the energy codes apply to them. In most energy codes you're using, when it comes to how many lighting watts you're allowed to use by energy code, you normally have the option of using two different methods of showing that you're complying with that code. One is called the building area method, and the other one is called the space-by-space method. And all of these codes have that as an option. You get to choose which one you use to show compliance. So the building area method, the way that works is you look in the energy code, they have a list of building categories, and you pick the one that matches your building type. So for example, if you're doing an office building, you would choose the office category from this building type. Corresponding to that, they list a lighting watts per square foot assigned to that type of building. And you basically just have to show that if you add up all the lighting watts in your building divided by the area, the actual lighting watts per square foot of your building have to be less than what's allowed at the building level from a watts per square foot. So you are looking at it at the building level, not at a more minute level of detail. So the advantage of this method of calculation is it's very, very easy to do. Really all you need are the total lighting watts for the building and the total square foot for the building, and that's it. It's very quick to do. It's also nice because if things get updated inside the building, like spaces get bigger or smaller, they get added, deleted, you don't have to worry about that. It's just the sum total of the square footage and the sum total of the watts that you need to worry about. On the downside of this, it is less flexible. It does not really allow you to take special allowances for more unique lighting applications. So say if you had a school building, you're using the school category, but it has a TV studio inside. This doesn't allow you to kind of account for more unique uses in the building. So then we get to the space-by-space method, and in this, you actually look at each space individually in the building, and you pick the category that matches that space. So they have, on a separate table completely, a lighting watts per square foot allowance for each specific space type. So things like private offices, open offices, corridors, all the different types of spaces you might find. And you use those individual spaces and the area for each space to come up with an allowance based on each space's individual allowance. You come up with a total lighting watts for the building using that approach, and then make sure that your total lighting that you're designing uses less energy than that. And I will go through an example which I think will make it a little clearer. So the space-by-space method, the advantage is that if you have one space that uses less watts than it's officially allowed to, so say the allowance is 200 watts and you're using 150 watts, you could have another space that is maybe using 50 watts more. As long as it all balances out at the bottom of the summation of watts, you're allowed to do that. So it's a way of almost borrowing extra surplus watts from one space and using them for another space. They also have additional allowances for specialty lighting such as retail, decorative lighting. They have a whole list of scenarios where you're allowed to use some additional watts that you wouldn't be able to do in the building method. The downside is it's very labor intensive. You have to constantly maintain a list of every space in the building, what the area is of that space, and what the code assigned category is for that space. So I will say for the example I'm doing, I picked the smallest example I could come up with to minimize the legwork, and that is actually our own office here in Washington, D.C. that we recently moved into. So I'm going to go through an example of both methods of calculation using our office as that example. So it's a relatively small office. It consists of open office, private offices, a number of meeting rooms, reception, and a pantry. So pretty much the spaces you would find in a typical office. The lighting we have is a variety of lighting types. We have some functional lighting like downlights and linear pendants. We also have some decorative lighting like an LED strip and a cove that lights a tile wall that we have, as well as a decorative pendant in our reception area. So we have a variety of lighting types. So if we use the building area method, and for this project we're getting LEED certification, and the version of LEED we're using references ASHRAE 90.1 2010. So this calculation was done to show per ASHRAE what our energy savings is. It's worth noting the newest version of LEED that has come out, LEED 4.1, which is just being rolled out, they have finally adopted a more recent version of ASHRAE 90.1. They're now using the 2016 version, which I think makes a lot of sense. In the past, LEED had gotten to the point where it was actually using an older version of the energy code than most jurisdictions. But for our purposes, we're using the 2010 version. So using the building area method, we looked up for an office building, what does it allow you to use? The allowance is 0.9 watts per square foot. Our office is just under 3,000 square feet, so that multiplies out 0.9 times 2890, gives us an allowance of about 2,600 watts to use in our space. When we add up the actual watts of our design lighting, we come up with 1,693. So that gives us a reduction of 35% over what the ASHRAE allowance is. And you'll see, especially for LEED for interiors, you'll get different amounts of points depending on how much of a reduction you're seeing over the ASHRAE allowance. So that's building area method. Pretty quick, not a lot of math involved. The space-by-space method is more labor intensive. So what I did and what you need to do for this approach is list each space in your building. So that's the left column there. The area of each space. And then I had to assign an ASHRAE 90.1 space type that corresponds to it. And there's some judgment calls, like our server room, they don't have a server room category, so I decided the electrical mechanical category is the most similar. So there are some judgment calls. If you look in that middle column, the ASHRAE 90.1 allowable watts per square foot for the space, you'll see a lot of these values are actually over 0.9 watts per square foot. So remember, the building area method, the blanket allowance was 0.9 watts per square foot. You're seeing here that a lot of the spaces, if you're individually looking at them, have a space allowance that's a higher number. What this means is if you have an office project that maybe has a whole lot of meeting rooms and a whole lot of private offices or enclosed offices, this may be worth doing because it's going to give you a higher allowance. You'll also see that we designate some lighting as being decorative. So there's a column there for whether there's decorative lighting or not, which is what we're kind of circling here. Space by space actually allows you to take an extra allowance for decorative lighting. So in our lobby, we have a pendant. That's decorative, so it gets counted separately and doesn't count against our basic allowance. Dining area, we have an LED cove, same thing. So that's another advantage of this approach. You'll also see the pantry area, it's allowed to use 220 watts. It's actually using 294 watts. However, that is okay because our totals at the bottom are within what the allowance is. So with this method of calculation for the same lighting, this is showing a reduction of 42% over ASHRAE. So if I was trying to get as many LEED points as I wanted to get, this actually would be a better way of doing it because it's showing a greater savings. However, as you can see, it is a lot more labor intensive, especially for a large building. And with that, I'll turn over to Sarah Schonauer.
Thanks, Sarah. So now that we're armed with sort of the building blocks of codes and standards and recommended practices, we're going to start talking about how we apply those, and we're going to walk through the different thought process that we have for designing a lighting system that meets the building occupant needs. So we break that down into 4 basic steps: identifying the needs, layering light to meet those needs, considering the control options for each layer, and then considering the ongoing maintenance and use of the system. So the first thing is identifying the lighting needs of the occupants. So who are the occupants? When we consider the buildings that we're designing, often there's lots of different types of occupants. So if you consider a hospital, for example, you may have, of course, the people that are visiting the hospital, who are the patients. You also will have their families that may have a different set of visual needs. Then there's, of course, the staff and the doctors, as well as the nurses and the maintenance folks that are making things work on the back end. So there may be a whole slew of different types of occupants to consider. So in addition to functional needs to do their jobs or to effectively use the space, we also have to consider those sort of base needs from an emergency standpoint that we just talked about. And then we can also take it a step further and think about the visual comfort of the occupants and their biological needs in those functional requirements. And finally, past the function piece, the owner or the client may have some aesthetic and stylistic desires that aren't necessarily functional tasks, but are certainly something we want to consider when we're thinking about the holistic design of a building. So once we have those needs sort of identified, and we can use our recommended practices to sort of start to identify what approaches would be good, we need to start thinking about the different layers for those needs. So the task layer is the first one that we consider, and that's usually talking about what you absolutely need to see. So working and interacting surfaces, the places where you need to actually read a newspaper, sign a form, small critical tasks versus larger tasks, like being able to see a face and recognize it across a larger space. Certainly wayfinding and in terms of being able to navigate the space, but especially in the egress situation where we need to also understand the exits of a space, and related to that, of course, walking surfaces and things like that. So all of those are kind of different tasks visually that we need to see. Then we move on to, well, what's kind of worth seeing? What are the things that we want to see? And this kind of may play into the stylistic goals. What are the focal points? What in the architecture is worth seeing? What do we want to highlight as a visual cue? And then we think about if any of those focal elements can actually contribute to the task layers we just talked about. If we're lighting a ceiling, can it also provide the general walking lighting, or do we need to have a separate layer for that? Next, we think about daylight, and that's kind of, is there daylight or isn't there? If there is, we need to think about how it's going to be incorporated into the lighting design. Is it going to compete with things? Do we need to control it? Is it going to be visually obtrusive? Can we actually use that and harness the daylight to do, again, some of those base tasks, being able to read, being able to see general things? Maybe not use that for the smallest focused task, but maybe we could use it for walking and other things, and can we save energy that way? Next, we talk about decorative lighting. Would the space benefit from decorative lighting? Is it needed for the owner's sort of stylistic idea of what the space can look like? And again, can it contribute to some of those other layers so we're not double dipping? And then lastly, we kind of fill in any of the gaps that are needed from an ambient standpoint. I'm going to talk about contrast ratios a little bit later in the presentation, but making sure that we don't have any excessively dark spots, that the visual composition is feeling balanced. And I usually do this last to make sure that we're not starting with an ambient layer and then layering on top of that, and in some cases overlighting the space. I do it last to make sure that if there are any gaps, we fill those in. And I just add this at the bottom, that those are the different layers, and then we always need to be checking against the lighting power density budget that Sarah just explained. We don't want to overlight the spaces for the sake of overlighting them, which is why we keep checking back that these layers can contribute to that original task layer or the other layers that we're considering in our composition. Right? So once we've got our layers, we need to think about how we're going to control them. And usually it's a different strategy for different types of layers. Some may require a lot of flexibility for users. Some may be perfectly happy being automated based on time of day or whether or not sensors detect presence of people. So we usually need to think about what needs to happen from those from a manual standpoint. Then we think about what's required from a code requirement and an energy saving standpoint. And then I usually say whatever else can be automated after that is usually a good way to finish out that kind of consideration. And lastly, our fourth step is once the system is designed, how is the system going to be used in the future, and how are we going to maintain it so it continues to be effective in terms of the steps that we just walked through. So we certainly need to consider the overall energy consumption and the life cycle of the system, and then those maintainable pieces. Training is usually a good place to start, especially as our control systems get a little more advanced. And other future-proofing measures that we can build into our designs, high life of LED sources, that L70, or we're even seeing L80 or L90 from a life standpoint. High-end trimming and task tuning are options that you have to sort of over-design the system on day one, dim the lights down to a little bit of a more acceptable level, and then extend the life of the system by ramping that back up as the L70 sort of depreciates over time. Specifying common driver types is another way to future-proof your system. Working with your manufacturers to try to use the same types of drivers so you only have to stock one. Most of us know that the driver is the first thing to go in an LED system typically. So considering common driver types is something that we can do to combat headaches down the road. And also having some attic stock of those drivers of typical LED modules, if you have them, is a good idea. And lastly, as you're designing a system, thinking about access. A lot of LED systems are getting smaller and smaller, and we may have a temptation to put them in a smaller and smaller detail or cove, etc. We do have to think about when and if the system does have a failure, we need to be able to get into there. We need to be able to use human hands to get into a cove. We don't have automated robots for that yet. So thinking about access is important even with our newer technologies. So I'm going to flip it back over to Sarah to talk a little bit about controls.
Thank you, Sarah. So this presentation, it's not focused on controls, but controls obviously are a really inherent part of lighting systems now. So I'm still going to just touch on some of these strategies a little bit. However, if you do want to get more in-depth information, I was part of a control-focused webcast last year that we'll have a link to in this presentation, and there's some additional links and resources there for more in-depth coverage of that topic. I think the thing to kind of look at with controls and energy codes, so the energy code has a watts per square foot allowance for different space types in buildings. And what that allowance is, it's calculated as if you have all the lights on at 100%. So if you turn all the lights on, full output, that is the watts per square foot that is used to show energy compliance. So that's kind of the first level of coverage and requirements that the code has. On top of that, the code has lighting control requirements, which are then applied to that lighting that you've designed. And while a lot of times I think we look at energy efficient projects as saying like, oh wow, look how low the watts per square foot are, really energy consumption is kilowatt hours, which is an amount of time that you're using power over an amount of time. So watts per square foot does not really tell the story of how much energy a space or a building, how much they're using. So it's something to keep in mind. Watts per square foot, it's a very straightforward metric to show how potentially efficient a lighting system is, but the real story is in how much that system's actually on and operating. So when you think about controls and how it impacts energy, the benefit of controls is it limits how many hours per day you're using the lighting through vacancy sensors, and it reduces the output of your lighting fixtures through either manual dimming or photosensor dimming. So when you think about it, you could have a very efficient, a low watts per square foot, say you have a 0.5 watts per square foot office, but the lights are on at 100% for 12 hours a day. Contrast that with a space that is maybe using 0.8 watts per square foot, so it's using a higher watts per square foot. However, that system, the lights are dimmed down most of the time and are turned off for half the day. Really, even though that one system has a higher lighting watts per square foot, it actually can be using less energy if the controls are applied correctly. So it's something just to keep in mind. While we look at watts per square foot, the real story is in the kilowatt hours, and that's where controls come in to really try to reduce the actual power consumption. So after that short section, I'll turn it back over now to Sarah Schonauer.
So I'm going to talk a little bit about human-centric design, and truthfully, this could be a topic all in itself for an hour or a day or a month-long presentation probably at this point. If you're paying attention in the space of engineering and lighting, you're definitely, you've heard this topic come up, human-centric design. And really, what it is kind of just advancing the idea that we've always had that it's good practice to design around people. But now we're actually having some science back up why certain technologies and certain approaches actually, we have quantification of benefits as to why we may spend a little bit more for some of these technologies. So we're going to talk a little bit about these sort of approaches, and really what it boils down to is this idea that it balances out, holistic systems balance out the different needs of a design, and it doesn't just sacrifice visual comfort for efficiency or other sort of triggers. It looks at things in a more holistic way. So there's many techniques that you can use to sort of advance this idea of designing around people, and here are a few of them we're going to talk about. The first one is about visual comfort. Visual comfort is something that, again, as LEDs are sort of taking over the lighting world, very powerful, very efficient source, but also can be extremely bright if it's not controlled correctly. So that translates into our design process, again, to that idea of contrast ratios. 10 to 1, so 10 to 1 in terms of brightness when you're doing illuminance calculations or luminance calculations is kind of the threshold for comfort. When you're over 10 to 1, you're starting to feel, you're visualizing that intense brightness, and you can lead to things like migraines and headaches. 3 to 1, 2 to 1 is sort of the threshold of being able to really see a differentiation between things. So if you're trying to make things pop, you need to be looking at 3 to 1 to 5 to 1, but you really do want to stay under 10 to 1 for general lighting and for most applications that we deal with every day. Another thing to consider is capping lumen output. Just because we can pump out 3,000 fixtures in a downlight doesn't mean we necessarily should. And so another good rule of thumb for linear fixtures is to use something around 500 lumens a foot. Anything more than that can be too bright in the field of view for an extended time. And that's, of course, for typical applications, maybe a 8 to 10 foot ceiling height. 500 lumens a foot is appropriate. When you start going to higher ceiling heights, it may be okay to go up to 750 or 1,000 in some of those higher packages, but generally speaking, 500 is a good place to be. And another thing, of course, to do is to consider indirect fixtures. When you don't have the opportunity to look into the source, you're certainly going to reduce your opportunity for visual discomfort. Two more quick things. Smaller apertures definitely increase the perception of glare. So 1,000 lumens out of a 6-inch downlight is going to feel less bright than 1,000 lumens out of a 2-inch downlight. So we need to be thinking about the appropriateness of the scale. Just because, again, we can do a very small aperture doesn't always mean that we should. And so there's a balance there. Another good rule of thumb is to look for downlights when you're specifying for 45 to 55 degrees cutoff, which has a deeper cone, rather than those very popular, very inexpensive surface-mounted sort of downlights that are edge-lit and you have all the brightness right at the bottom of the fixture. They cost a little more. We talk a little bit about high-quality specification grade. They do cost a little more, but that visual comfort is very important for people over time. I'll just point out, if you've ever heard that 330-300 rule that is very popular to discuss in real estate, it's kind of the scale of investment. So in terms of the pie of where owners spend their money, a very small amount is on the building and the energy, and then there's the systems and the way that it actually hits the bottom line, and then finally the 300 is the people. The vast majority of money that owners spend is on the people that they employ and the salaries and the benefits and things that go into it. So any small increase in productivity and satisfaction that's going to make people perform better actually has a huge benefit on the bottom line. So these small things like giving people comfortable work environments reduce incidences of people not coming to work and having to use PTO and benefits and other things. So this is how this all ties together. Another strategy in terms of designing around people is giving people control over their environments. So using these accessible controls like dimming and switching, taking advantage of the new technologies that we have in lighting with the LED platforms of color tuning or color changing, giving people these accessible controls through apps, through manual stations, et cetera, has a corollary between people being more satisfied and, again, maybe performing a little bit better. So that idea of designing around people and satisfaction is really at the heart of human-centered design. There's other technologies that I'm going to just briefly mention because, again, we could talk all day about what the industry is learning about these, but CCT, correlated color temperature tuning, seems to have a lot of different ways we can design for positive impact. So we know from the work that's being done by the LRC that in educational settings, there is a corollary between being able to focus and being able to change the lighting environment. Being able to change the color temperature from warm to cool seems to have anecdotal evidence that are saying that students are being able to pay attention and task switch easier. So learning more about that and case studies that are sort of focused on that technology and, again, quantifying the benefits are what kind of offset some of the costs of these systems. Again, if test scores are higher, that's a good driver for employing some of these new technologies. And then when we talk about smart systems and IoT and connecting systems for basically various forms of collecting data and using that information to inform the way people use spaces is another place that we're starting to see the industry just really burgeon with all kinds of new information. Those technologies certainly can have an impact on the way people work, and so they're another place that we could consider as we talk about holistic lighting design. Natural light and views have obviously been a part of design for a long time for a lot of different reasons. And again, we're starting to see real science pushing the fact that having access to different types of light, different spectral qualities of light at different times actually has a biological effect on the way we feel, the way we feel alert, whether or not we're being able to perform at our top peak. So learning how we can harness those technologies and deploy them in our designs is another thing to think about. Daylight comes with a caveat that it always needs to be considered when you're talking about daylight. We have to talk about visual comfort and control. The electric systems that we have today are still no match for the sun. As bright as our LEDs can be, sunlight is still vastly more powerful, so we always need to consider how it's going to be integrated, not just inviting it in whole hog into spaces. And lastly, just touching on the environmental impact, when we talk about human systems, we of course need to consider future generations. So we talked a lot about codes that affect energy consumption today, and certainly that's an aspect. You may have heard about material health and cradle to cradle, and whether or not the systems and the manufacturers of the systems are considering how the raw materials are being found, delivered, mined, recycled at the end of their life, and how they go back into our environment. That's a great thing to be considering when you're looking at specification of high quality fixtures. What happens at their end of life? And then kind of a different take, you know, the idea of making sure that an electric system doesn't prevent you from enjoying nature's lighting system, which of course is starlight. That's another aspect of human-centric design, which we didn't really talk a lot about exterior lighting today, but when you think about exterior lighting systems, that's certainly something we've got to consider. So as you can see, there's a lot of things we could talk about in terms of human-centric design, but really I think what it boils down to is that there's lots of different considerations that go into designing a system holistically, and as our toolbox is advancing, we have a lot of new opportunities and knowledge to really leverage to deliver even more successful lighting solutions. So that's a ton of info that we threw at you. I think I'm going to be handing it over to Jack so we can dig into some specific Q&A if anything on there that we've covered requires a little more discussion.
Thank you, Sarah Lopano and Sarah Schonauer, for that terrific presentation. And now the double Sarah expert presentation team will answer questions about the topic. Type your questions in the Ask a Question box on your screen, typing the presenter's name and last initial before your question so that I know who should answer it. We'll get to as many questions as time allows. Additional information will be posted online at www.cscmag.com with the archived version of the webcast. Okay, as a reminder, you may earn one AIA CES approved learning unit for this event, and you need to pass a 10-question exam. To take the Learning Unit exam and to download your AIA CES certificate, use the Learning Unit Exam tab option at the top of your screen. The exam will open in a new browser window, and you can complete the exam after the webcast. However, the link will break when the webcast signs off. The exam will be posted on the Consulting Specifying Engineer website with the on-demand version of the webcast. Okay, before we get to the questions, we wanted to let you know about another opportunity to earn continuing education credits. On CFE EDU, an interactive educational platform, you can register for the course Arc Flash Mitigation. There are many other courses to choose from too. Click on the link on the downloadable PDF to get to any of the CFE EDU courses. Okay, let's get to some of these questions now. First question goes to you, Sarah Schonauer. How much coordination with lighting reps do you typically see?
Sure. Thanks for that question. That would really depend on the project, but if we're talking generally speaking, we do use our reps as a resource. They are very plugged in to what's happening in the world of technology and certainly in terms of the world of cost. Whenever we use a rep, we always do have to remember that they come with a bit of a bias. And as their primary focus is sales, they usually are only focused on the lines that they represent. So sometimes that can be a little limiting. But they are a great resource in terms of being able to narrow down what is a very crowded field of products to what the real high quality elements are and who's really using the right technologies and who's thinking about the kinds of things that we talked about today. So I would say, generally speaking, reps are a part of the process. I know some people lean on them more heavily than others. In our practice, we certainly use them as a trusted advisor when it comes to their products, and we try to leverage that as much as we can.
Thank you. Sarah Lopano, please outline the code requirements applicable for retrofitting existing lighting installations.
Sure, and this is a scenario where actually looking at ASHRAE 90.1 versus IECC, they have somewhat different requirements. And the question is basically, at what point do you have to upgrade the entire space to meet the current code? And usually that applies more to controls. That's where I see this question. An owner wants to replace the lights in an office, but they really don't want to start dealing with all the controls and bringing that up to code. So IECC is the slightly less stringent between the two. What that says is if you replace less than half the luminaires in a particular space, you do not have to bring the entire space up to code. The one caveat is that you can't increase the overall lighting power density of the space with whatever you change. So IECC, if you replace less than half the fixtures, it exempts you. ASHRAE, on the other hand, their cutoff is actually if you replace less than 20% of the connected lighting load, then you don't have to comply. Otherwise, if you're replacing over 20% of, and they look at it from a watts term, over 20%, you have to bring the entire space up to current code requirements, which includes controls. They do have some other exceptions. If you're just replacing lamps or ballasts and drivers and fixtures that are remaining in place, that's fine as long as you aren't increasing the lighting density. And they also make it clear that routine maintenance or repair, if a driver fails, you don't have to bring the whole space up to current code in that scenario as well. So they do vary, so it's a good thing to check on your projects.
Sarah Schonauer, what happens when the owner gets overwhelmed?
That is not a fun time, but yes, that certainly can happen. There's a lot of very meaty technological stuff happening in lighting right now, and it's easy to get overwhelmed. I think the first thing is, of course, trying to do some good client education. And if that is the part that's overwhelming, I think then reaching out to another resource. Lighting designers, if they're not already part of your team, live and breathe this kind of level of, technical expertise every day. And so they're a great resource to help explain some of these concepts, but also just making sure that you understand the level that your client needs to know. Sometimes it can be more beneficial to stay at a high level and then in particular areas go a little deeper. But I think generally keeping it as basic as possible is a good strategy, and then enlist resources when things get a little hairy.
Okay, Sarah Lopano, where cubicles come with under bookshelf lighting, does that count in calculating the watts for the entire space?
Sure, that's a very good question. I will say it depends. You do need to check the specific code and year of the code because that's something that has been changing. Some versions of the codes say that if you have integrated occupancy sensors in those task lights, that you are allowed to exempt them from your calculation. In all cases, though, if you do not have any occupancy sensors, if it's just on either manually or however, then you do have to count that towards your watts per square foot. And there's a little bit of kind of a honesty thing there. There's some projects where we design it and we have no idea what furniture is going in, and there's only so much we can do in that scenario. But especially if you're relying on task lighting to contribute towards your foot candles, you are supposed to count it. But just check the specific code version because if you can do integrated sensors, there are some versions of the code that will allow you to not count those watts. Good question.
Okay, here's another good question, and Sarah Schonauer, this one's for you. How do you approach the value engineering fund phase of a project to maintain critical holistic lighting design decisions?
That is a well-worded, I'm sure, tongue-in-cheek question with the fun phase of value engineering.
Hard to say, too.
That's a great question and a great point to bring up. I kind of mentioned a couple times that some of these technologies come with a slightly higher price tag. And so then when we get to sort of the traditional, well, I thought it was going to cost this many dollars per square foot, why all of a sudden is the lighting system so much more expensive? I guess there's a multi-pronged approach. One is getting in front of the client to explain the concepts as early as possible. One thing we've been talking about in my practice is at the SD level, making it clear why we're making these moves and tying it to, again, those scientific benefits or at least the anecdotal benefits of why these might be a good move for the client, so they can become invested in the technology that they'll ultimately be purchasing. The other piece is reminding the client that value engineering at its heart was always about trying to look at different ways of approaching the same goal without sacrificing quality. And I think that's sometimes overlooked in today's sort of exercise of value engineering, where we're really just focused on eliminating costs. And it's a lot of this is about pointing back to science and saying the reason that you're paying for a downlight with a higher price tag is because of the visual comfort that has an effect on blah, blah, blah. So it's really about being educated enough to take that conversation back to the beginning. And of course, timing is everything. That's not an easy conversation to have late in CDs. It's better when we have the owners on board early so they can actually be our best allies when it comes to those items on the chopping block.
Okay, Sarah Lopano, your turn. If a building is split 50-50 between office spaces and manufacturing spaces, and
yeah.
Can we use
go ahead.
the building method in
yes.
watts per square foot approach? If
yes.
so, which space? You got it.
I got it. It's a good question, and it's something I didn't get into that level of detail on my slide, but if you do have a scenario where the building actually, in reality, has two very separate finite uses to it, the code does allow you to count the warehouse side of the building as its own building with the building area method, and then separately take the office side as its own building area. So there does start to be a little bit of kind of gray area between, at that point, space by space versus building area. I would say if it's that kind of scenario, you may as well take the warehouse as one building and the office as a separate building for the calculations. You probably still don't want to go to the detail of space by space. But yeah, you can actually divide large portions of the building up if it makes sense for your scenario.
Okay, Sarah Schonauer, your turn. How does the use of LED fixtures correlate with the energy level calculations?
Sure, good question. Well, if you were to do a side-by-side walking through the different charts that the tables that ASHRAE has put out for maximums and look, for example, at offices and look at what happens as those 3-year iterations have rolled out, you'll notice that there's generally a trend down in the allowances. And that correlates pretty well with the fact that LED technology is becoming more ubiquitous and it's becoming more affordable. And by forcing, from an energy code standpoint, the budget of energy to be less, it's kind of forcing adoption of those LED technologies. So there's certainly a correlation there. I will mention that there are a few categories that don't necessarily trend down. Labs is one that comes to mind immediately, where actually sometimes those allowances have gone up. And I think those have to do with the types of work that are being done in labs these days. Nanotechnology, et cetera, requires higher light levels, or we have learned that higher light levels help. So generally trending down, a couple places where that doesn't always follow through, but I think that they're highly related to the fact that our technology allows us to do much more energy efficient designs.
Okay, Sarah Lapano. We've got some interesting dialogue going here, isn't it? 10% of fixtures being replaced for IECC and not 50% when meeting the energy code comes into effect. I believe the 50% was an error and has been corrected to 10%. Can you address that?
Yes, and Bradley, who sent this in, thank you. I actually was looking this up when the question popped up. For the content of our presentation, I was referring to what I found on my code resources as the most recent version of all these codes, but you are correct. I just looked into it. The 2018 version of the IECC, the original issue of that document, which is what I was using, said that lighting alterations under 50% don't have to be brought up to current code. And you are correct, Bradley. I looked into it, and they did issue an update to that after the original document went out. They are actually at 10%. So I stand corrected. The IECC 2018 is more stringent than ASHRAE. It's a 10% cutoff for lighting alterations, whereas ASHRAE is 20%. So thank you for mentioning that and giving me the chance to correct it.
Nice comeback. Sarah Schonauer, the 10 to 1 ratio you mentioned is the maximum to minimum allowance luminance values or average to minimum?
Generally, average to minimum would be the safer way and the more conservative way to use that. Max to minimum would give you, a higher percentage there. So using average to minimum is a good way to go.
Okay, Sarah Lapano, if using ASHRAE 90.1 Appendix G for a project, can the lighting budget in watts per square foot be exceeded if there are other trade-offs in the building, such as building envelope or more efficient HVAC systems, etc.?
Yes, that's a great question. So, and I'm saying this as an electrical engineer who does not do our energy modeling, but so ASHRAE 90.1 Appendix G, that gives an alternate compliance path where you essentially model the complete energy performance of the building holistically and compare that to a standard ASHRAE 0.1 bare minimum code compliant building, again, holistically. So in that scenario, you're actually looking at the total energy consumption of the building compared to the ASHRAE baseline total energy consumption. So yes, in that case, I believe, I'm sure someone will correct me if I'm wrong, but it really looks at the total energy consumption. So you could have lighting that doesn't perform as well, but an envelope that performs very well, and that's really more what it's looking at. The system we were just going through with the tables and everything, that's the more prescriptive method where each discipline complies with their own section, and that's how you meet the code. Appendix G allows the entire team to collectively show that the building as a whole complies. So that's a good question. And a lot of LEED projects end up going that way if it's new construction. They normally use the Appendix G method of showing energy improvement, which includes everything, not just lighting.
Okay. I'll throw you both a curve. Okay, we have time for one more question, and I'm going to direct it to both of you because the viewer directed it to both of you. Sarah Schonauer, we'll start with you. The question is, are there specific standards or guidelines for 100% down lighting for dark sky areas?
That is a good question. The standard that I'd point you towards would be the Model Lighting Ordinance, which I'll probably misspeak. There's a couple of dark sky associations that are looking to put some numbers to design around. But the MLO is basically, it's a way of walking through the right type of lighting for the community that you're designing for. Obviously, doing an exterior design for a place in an urban environment is going to be very different from a very rural environment or a very remote environment. So it may have different requirements. So the MLO walks through those different things, and it's probably the closest thing we have to a real sort of guideline standard to talk about how we really protect dark sky.
Yeah, I'll just add on to that. I think the goal that they had in developing the model lighting ordinance was to get jurisdictions to adopt that as a standard code. So just the way ASHRAE 90.1 can be adopted as a code, these various groups interested in dark sky got together to write a standard that could basically be used as a code. I think there are also some jurisdictions that have kind of made up their own rules for this, and those are certainly in place as well. But I agree, model lighting ordinance is kind of the standard that's out there right now. Whether it's adopted as a code or not, that's kind of what is variable right now.
Excellent. Good responses, both of you. I'd like to close by thanking our experts, Sarah Lopano and Sarah Schonauer, for sharing their extensive knowledge and understanding of lighting design and its many facets. I'd also like to extend a special thank you to our sponsor, Lutron, for supporting today's webcast. And now that we're just about done, we want to hear about what you thought of this educational session. A short survey will pop up on your screen as soon as the webcast ends. Please take a moment to complete it. We do use this information to improve our webcasts. Finally, on behalf of Consulting Specifying Engineer and CFE Media, thanks for attending this webcast. This now concludes today's webcast event. Thank you for joining us, and goodbye.